Hello everyone, my name is Jack Hassamon. Today I will talk about manufacturing systems. Manufacturing systems in this topic means a company that conduct manufacturing process as part of their business activities. So what is manufacturing process? Manufacturing process is a process that converts raw material into physical product that customers want. Sometimes the process is very simple, like cutting a long steel bar into shorter length. Sometimes the process is more complex, and company may need to do many processes to make final products. No matter what, manufacturing process consumes resources. For example, we need to use a machine and special tooling to perform manufacturing process. The machine needs electric energy and human operator to supervise. Physical products can be anything: your mobile phones, electric car, gold coins, laundry detergent, paper napkins, a bottle of shampoo. Manufacturing companies tend to have similar structure. For sure, they all have manufacturing department, probably the biggest part of the company. Within manufacturing department, it has operation division that makes up all manufacturing machines and human operators. Manufacturing departments also includes materials management, manufacturing engineering, and quality assurance. Material management deals with incoming raw material and outgoing finished goods. Manufacturing engineering focuses on improving manufacturing operations. Quality assurance makes sure that the entire operations are performed according to quality standard. Besides manufacturing department, the company needs many other departments: research and engineering for new product development, and introduction of new machines to manufacturing operations. Purchasing department is in charge of buying and hiring resources outside the company, such as buying raw materials, parts, hiring subcontractors to perform some tasks for the company. Finance department manages all the money issues, such as accounting, payroll for all staffs, budgeting, and financial planning. Sales and marketing manages market analysis, sales, customer relations, field services at customer's site. So a manufacturing company is a complex organization. Let us focus on product cycle. Everything starts from design. Marketing department determines product specification and features. These are collected from both outside and inside companies. Then, research and engineering department starts the conceptual design. What does the new product looks like? Is it feasible to make something like that? Do we need to buy a new machine to make this product? Once the conceptual design is approved, design team will check if there is a technical standard for the products, then start to create detailed drawings. All the components for the products are specified. Almost all new products must be prototyped. This is done at varying degree, depending on how new the product is. If the product is very new to the company, we may want to see its sizes and shapes first to get a feel for the products. We may not need to have prototype made with exact material in the beginning. For not so new products, we may be able to create exact products. Once the prototype is approved by marketing team, final detailed drawings are created. Materials for all components are now finalized. Its manufacturing sequences are documented. Critical issues in manufacturing process are reviewed. Generally, company will start with pilot production, making small batch sizes to see whether there is any issues on product quality and cycle time. Then mass production begins. Normal product inspection, quality control procedures are performed. Then product packaging, product instruction are included into the product. Finally, we have the product ready to be shipped to customers. Every issue we encounter regarding the product during the entire process is fed back to design team. So the product specification will be improved in the next design cycle. As an engineer, we can take on one or many roles in manufacturing company. We can work in R&D for product improvement, designing new product or new machines. We can work in production to control and improve manufacturing process. We can work in maintenance or engineering for tooling design, machine and tooling maintenance and improvement. We can work in quality department to make sure that measuring equipments are in good condition. Raw material, manufacturing process, and final products are according to quality specification. Finally, we can work as sales engineers, assisting customers to select the right product. If we look to buy a product, any product, it is very likely that we have many choices in the market. Competition is everywhere. Manufacturing companies are competing to sell their products to customers. To fight for customers' money, they compete on 5 key elements: quality, lead time or availability, price, product development, and product flexibilities. Customers usually ask, does the product meet my expectation? If we order now, when can we get it? Is the product sold at good price compared to other alternatives? Does the new product have interesting or useful features? Does the product has many models and the one that suits me? Internally, company asks about these same 5 elements, but their questions are slightly different. They ask, do we have good product specifications? How do we control raw material, manufacturing process, and final product quality? How do we plan our production to fulfill inventory? How do we shorten our supply chain? Where can we cut costs? How do we cut costs without affecting quality? Which product features do customers want? What kinds of new products do we need? How many products models do we need? How do we manage our production to various lot sizes? Most likely, quality, product development, and flexibilities are based on marketing and designers' decision. We will focus on what manufacturing engineers can control, which are production lead time and production costs. Production lead time is important to keep up with customers' demand. Manufacturing or building a house will be very different from manufacturing bottles of drinking water. Generally, if we need low production rate, our manufacturing facilities will have low level of automation. If we need high production rate, our manufacturing facilities will have high level of automation. This graph shows that as required production rate increases, as in x-axis, going from left to right, the machine tool required will be more specific. In experimental or prototype stage, we can use manual or basic machine tools, denoted by 1. As we start to manufacture in small batches, we need general purpose machine tool. Manufacturing large batches, high volume or mass production requires special purpose machine tool or automatic production line. Figure 5 and 6 in the graph represents computer control machines that can be used for both small lot and large batch sizes. So we need to select the right level of automation and machine tools for our production. Let us turn to manufacturing costs. For manufacturing companies, cost is how much money we spend to manufacture one piece of product. This cost consists of fixed cost and variable cost. Fixed cost is the cost that we must spend before producing a single piece of product. We need to buy machines and tooling first. We need to have a manufacturing plant built. All these are invested before we produce. Where variable cost is the cost that must be spent when producing each unit of product. Whatever we can measure going into a product are included in here. Raw material, packaging material, human operators, time to supervise machine, electricity, consumables such as lubricant, grease, glue are all included. For a good explanation of manufacturing cost, please study these two videos. When companies keep track of costs, they usually find that material cost is around 50% plus minus 20% of the total cost, while direct labor is about 10 to 15%, overhead is around 20 to 30%. Material cost tends to be the highest or the largest cost component within the total cost. The interesting point for us is each manufacturing process will throw away some raw material. Percentage of raw material thrown away is called scrap rate. Each manufacturing process has different scrap rate. So if a product can be manufactured by two different processes and final product from two processes is exactly the same, if we pick the process with high scrap rate, we need to buy more material to start. That is, process with high scrap rate will lead to high material costs. For example, machining process has a scrap rate in the range of 10 to 60%, while powder metallurgy will have scrap rate of only 5%. Let us take a look at how we calculate direct costs. Process A requires raw material bar 6.4 meter long, cut into 12 pieces. Each piece is then converted by process A into a product. The 6.4 meter bar costs 340 baht each. Process A requires 2 workers to operate, resulting in 60 pieces per hour. We need to pay each operator 60 baht per hour. The tooling used by process A costs 80,000 baht. We will use tooling to produce 5,000 pieces of product over its lifetime. What is the total cost per piece, considering these three cost components? If we know that process A has a defect rate of 3%, if we plan to produce 1,000 pieces of product, what would be the total cost? So, what exactly are three cost components? So we need to focus on material, labor, and tooling costs. For material costs, we pay 340 baht per bar, and we can make 12 pieces of products. So the material costs come out to be 28.33 baht per piece. The labor cost, since we pay 2 workers, 60 baht per hour per worker, and we can create 60 pieces per hour. So that labor costs come out to be 2 baht per piece. Tooling costs, we pay 80,000 baht to create 5,000 pieces, so that come out to be 16 baht per piece for the tooling cost. The total cost is 46.33 baht per piece. To make 1,000 pieces of product, we cannot use 1,000 pieces of raw material. We need to make up for this defect rate of 3%. So we need to prepare 1,030 pieces of raw material, and that would cost us 47,719.9 baht for the total cost. This type of cost calculation is very important in our engineering work. It will be checked in our midterm exam. So please make sure you understand this Should you have any question, you can leave your question in our Google Classroom. I will answer all of them. That's it for now. Have a great day. Goodbye.